Good morning, you guys. It is Monday, March 23rd, and our lecture today is continuing on with some NMR analysis. So your job is to be working through our packet, which you all should have gotten, I believe, before the school shut down. So this little packet here has a bunch of NMR analysis in here. This video will be analyzing some of the spectra in here, and then your job will be to complete it. So again, you should be working daily in all this craziness. Continuing your schoolwork is normal, a good time that you're home a lot, to be just taking the time to really study in all of your classes. So let's get started. Okay. So we've got lots of different spectra, NMR spectra in this packet. Some of them will have the integration of your signals, giving you the number of hydrogens that are responsible for that particular signal. So these are 3 hydrogens giving this particular signal, which if you look close is a triplet, because I can count the 3 lines, 1, 2, 3. You have 4 hydrogens here giving a multiplet. So remember, we should know what a multiplet means. We'll write that down in just a minute. We have 2 hydrogens right here giving another triplet. And then, of course, downfield here, we've got 1 hydrogen responsible for this signal. And then, again, at this point, you should be fairly comfortable knowing what these chemical shifts mean. What do those approximate values mean? That's really important, and you should be comfortable with counting splitting patterns and being able to figure out what does that mean? How many neighbors are we talking about? And then slowly putting things together. It's okay to put a structure down that may not be the right answer, because you always go back and check your work. And right here, does your answer make sense? Does it match the spectrum, not only in the splitting pattern, but also from the chemical shifts? Sometimes there might be more than one answer, but usually you can narrow it down to 1, maybe sometimes 2. Alrighty, so notice you have no molecular formula. So you won't always have a molecular formula like the ones we did in lab. Sometimes you won't even have the integration values, but let's see how that helps us in this particular spectrum. So right away, we notice we have this. So 1 hydrogen has how many equivalent neighbors? Well, this is a singlet. And a singlet means we have 0 equivalent neighbors, because 0 plus 1 gives us that singlet. Right? So this 1 hydrogen has 0 equivalent neighbors. So we can't give him any neighbors. And then this shift right here tells us a lot of information. So thinking of hydrogens that are super de-shielded, right? Really close to electronegative things. Lone rangers don't have a lot of electron density around them to protect them from the magnet. So it takes a lot of energy to spin flip. Excuse me, still battling my cough, but sounding much better. This is our carboxylic acid region. So just maybe writing down a little piece of our puzzle here. This little hydrogen right here, that's his signal. He's super de-shielded. If we look at the adjacent atom to which it's attached to, this carbon, there's no hydrogens that are going to be on here. Okay, and this certainly wouldn't be an aldehyde. There's no 9 to 10 there. So he has no neighbors. We already have a piece of our puzzle. Now let's kind of shift over here, and then we'll kind of put our pieces together. Right here, we've got 1, 2, 3. We have a triplet. Okay, so how do we get a triplet? Well, if you have 2 equivalent neighbors, 2 plus 1 equals 3, okay, which would be a triplet. So this is telling us that we have 3 hydrogens have 2 equivalent neighbors. Okay, there's that 2. Okay, so we have a group of 3 hydrogens that have to have 2 equivalent neighbors. So if we're thinking what that might look like, and remember, we're kind of in our alkyl area, really upfield, away from electronegative stuff, what would that look like? Well, 3 hydrogens is a methyl group. And if we want them to have 2 equivalent neighbors, That would be a CH2 group that we're looking at right there. Okay, so this triplet would be for these guys right there with their two equivalent neighbors. Okay, so we've got another piece of the puzzle. And then we've got to figure out, you know, what's sort of attached right there to that carbon. We don't know yet, but that's not a problem. We're not done analyzing. Now, if you look right here, this is a multiplet. Okay, and you've got 4 hydrogens. Some people go, well, you can't have 4 hydrogens attached to a carbon. Well, no, you're not going to have 4 hydrogens attached to a single carbon in a big structure. You're right. But how would you get a grouping of 4 hydrogens? Okay, so a grouping of 4 hydrogens is typically 2 CH2 groups. Okay, so we kind of have another piece of our puzzle. And what does a multiplet mean? Well, a multiplet means, again, you have unequivalent neighbors. So the neighbors on the right and the left side of you have to be different. Okay? Now these 4 hydrogens are next to these 3 hydrogens. So if we think back to this puzzle, we had this group right there. So this CH2 is probably the same as this CH2 group right there. Okay? So I'm going to go ahead and bring down my other little CH3 that we know was that upfield triplet. Okay? So here are these 3 hydrogens giving a triplet. These 3 hydrogens have 2 neighbors. So 2 plus 1 is 3. That's why we're seeing that triplet. Then we need to have 4 hydrogens that have unequivalent neighbors. So here are those 4 hydrogens. Let's look at this set right here, these methylene hydrogens here. You can easily see that they have unequivalent neighbors. To the right, they have a methyl group, and to the left, they have a methylene group. That would be 5 unequivalent neighbors. Okay, so that makes sense. Now these guys, we're not done with our puzzle here because we're still trying to figure out, you know, what do we have right there? So these guys have 2 hydrogens to the right, and then we need to make sure they have something that is unequivalent to the left, and that would be a total of 4 hydrogens that have unequivalent neighbors. So trying to figure out what that might be, well, we still have 2 hydrogens that are unaccounted for, right? So the only way to get 2 hydrogens that are equivalent would be another CH2 group. Usually that's the most common. So here we have 2 hydrogens that have, well, this is a 1, 2, 3, a triplet. What does a triplet mean again? We already talked about a triplet up here. 2 hydrogens have 2 equivalent neighbors. Okay, so we need 2 hydrogens that have 2 equivalent neighbors. So how do we get 2 hydrogens? Let's bring that down here. We're going to make this a CH2 group. There would be 2 hydrogens, and we need them to have 2 equivalent neighbors. Well, there are their 2 equivalent neighbors. And notice this region down here, that 2-ish region. That's usually is next to a C double bond O, which we do have a C double bond O in our molecule because we know we're dealing with a carboxylic acid. Okay. So we are ready to put our structure all together. And then really important, we should probably label this as a triplet as well. We already wrote what it meant. Again, all these analyses have to be on your paper, not just a final structure. So we've got this piece of the puzzle, and then we have this piece of the puzzle down here. So putting it all together and then making sure that we check our final answer. Okay, and then counting, I've got 1, 2, 3, 4 carbons there. So we've got a CH2, 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 CH3. Most important part, checking our work. Okay, so there are these 3 hydrogens that are upfilled. There's the 3 hydrogens. They should have 2 equivalent neighbors. That's why they have a triplet. So these 3 hydrogens have 2 equivalent neighbors. Okay. Now we have 4 hydrogens, also in that upfield region, in that 1-ish region, because they're far away from the electronegative stuff. They're giving a multiplet because they have unequivalent neighbors. Let's check. These 2 hydrogens have 3 hydrogens to the right, 2 hydrogens to the left that have a different environment. So that's why we're getting, again, this is a multiplet. These 2 hydrogens have 2 hydrogens to the right that are different from their 2 hydrogens to the left. These 2 CH2 groups have different environments. This one is next to a carbonyl. This one is next to a CH3 group. So that is our other multiplet. And of course, this was our triplet that we talked about. Okay. And again, all of this stuff is upfield. Okay, this is all in that 1-ish region. Okay, so again, this one was around 1 ppm. Your multiplet here is around 1.5 ppms. Okay, now our 2 hydrogens right here have 2 equivalent neighbors. So this is our triplet. And since it's adjacent to a carbonyl, that's in that 2-ish region, which we have seen before. And then lastly, we have our Lone Ranger, super de-shielded with no neighbors. That would be our singlet, right around 12 ppms. So we have all of our hydrogens accounted for, and we have our chemical shifts matched up as well. So I'm going to stop our video here. It's easier to upload when it's not quite so long, and then we will analyze another structure in our next video. Talk to you soon.